That is awesome. I just want to see you to play that piano that was right behind her. That looks beautiful. Perfect. Okay. So
two things I want to remind before we move on. One, for all of you who are attending today, we are donating $1 to Deaf Kids Code. So thank you for registering and attending. We hope, obviously, we want you to learn some great stuff about platform engineering, but you're also doing some good in the world too.
$1 per registration, not just $1. And we have to say that will be over $1,000. We had a lot of registrations, which is really wonderful. And they're still trickling in. So we're gonna be given a nice check of change. So that's awesome.
Now I'm going to add in our next speaker, Flynn. I would have done a costume change, but apparently I don't have a Buoyant or Linkerd shirt. So Flynn, let's talk about that.
I have the Linkerd stickers, but
how can you not have a Buoyant or Linkerd shirt? What is wrong with us, I guess, really?
Yeah, right.
I don't know. Maybe, I don't know.
It's so cute too. Linky's so cute. I love Linky.
I will correct it.
Yeah, we will definitely have to do something about that.
Yeah, we're happy to parade around and do the wardrobe change.
By the way, y'all know that we have Linky plushies in the CNCF store, right?
Yes. And if I was doing this from my desk, I would be holding up the plushie. I have a lot of Linky stuff. I've got the Lego. I've got the little squishy thing. So, but Danielle's kitchen is very clean here. Living room, whatever room we're in, it's very clean. There's no.
I'm kind of feeling bad that I didn't go and bring one of the Linky plushies out of my son's room so I could hold it up right now. But
there you go. It's adorable. Maybe.
Yeah, well, I have a very small Linky on my shirt though.
Oh, there you go. Yeah. Everybody else can go to the CNCF store and purchase Linky swag. I'm sure the CNCF would love that.
Yeah, I'm sure they would. We don't get anything out of it, but
you get the joy of knowing your community loves you so much.
Yeah, and we get to do things like do the project updates that everybody goes, oh, it's so nice to see Linky and William, whatever. But Linky,
exactly. Yeah, our priorities are okay. We're going to give you.
All right, we're gonna have your deck and let you take it from here.
Off we go. Yeah. So we originally titled this talk "Internal Developer Platform with Secure, Reliable, Observable Communication," and we really should have just pitched it as why your platform wants a mesh, because it does, even though that might not be all that obvious. I'm Flynn. I'm a tech evangelist with Buoyant. I work mostly with open source Linkerd. You can find me as Flynn on the CNCF Slack or the Linkerd Slack, or really almost all of the Slacks out there, honestly. So if you like the way this goes and you are interested in more service mesh type of deep dive stuff, every month we get together and do Service Mesh Academy to talk about service meshy things. The next one coming up is Linkerd outside of Kubernetes the easy way, as opposed to the demos I've done a couple other times where we demoed how to do Linkerd outside of Kubernetes the very, very hard way. So that one should be fun as well. Our agenda here today, I'm going to do a brief recap about why this whole microservices thing is so common today, about how developer platforms can help with the whole microservices thing, and a less brief look at how service meshes can help with the developer platform, which can help with the microservices thing. And there will be a demo. I would like to warn everyone that the demo is a very proof of concept-y sort of demo. And so it'll be fun to see what happens. So the TLDR of this whole presentation really comes down to microservices are a big deal these days because they are the only way that we've found to properly develop at scale. We know a bunch of ways to do operations at scale. Mostly they have to do with just horizontal scaling, but we have a bunch of ways we can do that. But we've only found one really good way so far to develop at scale, by which I mean throwing a ton of developers at something and having them all make progress, and that is microservices. That makes microservices kind of a big deal. Unfortunately, to actually get the most benefit from microservices, you have to have an enormous amount of information, and maybe more importantly, all of your developers have to be keeping in mind an enormous amount of information. Developer platforms help with the information, service meshes can help with your developer platform. So let's get into how we got here. In the beginning, of course, we had the monolith, where our application was a bunch of functions living inside usually a single binary, single address space, single process. We relied on the operating system to isolate our monolith from everything else. And the important thing here, the most important thing, the thing that defines a monolith, is that you have to build it and release it as a single unit. Any change that you want to make in a monolith, you must rebuild the entire thing. That also means you have to redeploy it and retest it, and it's a whole lot of toil. Another interesting characteristic of monoliths is that they tended to be developed in a fairly centralized way. There was often a single owner or maybe a single team that owned it, and this has advantages and disadvantages. I want to lean a little bit into this every change requires rebuilding thing. So if our developer Jane wants to make a change to one of these functions, and our other developer Jose wants to make a change to a different function, then what's going to end up happening is this dance where Jane will first go, put her change in, recompile the entire world, retest it, eventually decide it's okay, ship the source change, and then Jose has to do exactly the same thing, where he takes the sources with Jane's change, puts his change in, recompiles the whole thing, retests the whole thing, redeploys the whole thing. And you can play games with like, oh, well, maybe Jose could just give Jane his changes as a patch and she could incorporate them. It's just a slightly different technique for doing exactly the same thing. With 2 developers and 4 functions, this is not a nightmare. But as we start adding complexity to the monolith, and as we start trying to go through and add developers to our team, it rapidly becomes untenable. You literally end up spending more time resolving merge conflicts and running the tests than you do actually developing your application. This gave rise to the microservices architecture as a way of trying to get away from that. Instead of a bunch of functions inside a single process, now we have a bunch of microservices interacting with each other over the network. So we have multiple binaries, multiple processes, almost certainly multiple machines. And the most important bit here, the thing that defines the microservices architecture, is that each of these microservices is developed and tested and released completely independently of any of the others. So in this world, if Jane wants to go through and change one of the microservices, she just changes it and releases a microservice, and Jose can do the same. There are definitely things that you have to worry about in this world, but it is much, much simpler. Most of the things you have to worry about in this world that aren't on this slide have to do with things like if Jose is relying on being able to call something in Jane's microservice and Jane breaks that, then she just breaks Jose, right? That's actually not a problem that's specific to the microservices architecture. That's specific to developing in teams as a whole. So that is not actually a problem that microservices make worse, in the sense of they don't make it worse by having individual services changing at once. We're going to talk about a way that they do make that worse in terms of information you need. But on the whole, as our microservice application gets much, much more complicated, then it's really not a big deal to also increase the number of developers working on it by allowing the developers or developer teams to work on specific microservices and to let them go ahead and run in parallel, where they can develop things, they can release things, they can just go ahead and do it. And this is how you get to the whole developing at scale thing. Now, let's talk a little bit about gotchas in this world. That bit where you can release independently, that is not an option. That is a requirement. If you have a world where Jane has to release all of the microservices at once in lockstep before Jose can go through and then re-release all of them in lockstep, you do not have a microservices architecture. At that point, you have a distributed monolith. That can help with some things like dependency management, but it will not help you actually develop at scale. It probably isn't worse than a monolith. than a non-distributed monolith, but it is definitely not where you want to be. Another thing that's worth pointing out is that if you really want to do this well, then Jane and Jose need direct control over their microservices. So if we throw in another person in operations and we require Jane to take her changed microservice, hand it off to ops, and then let ops put it into the cluster rather than Jane doing it directly, all that really does is slows things down, introduces friction, and frustrates Jane. Again, with 2 developers, this is not the end of the world. You can make this work. But imagine having 1,000 developers, and imagine the life of the ops team. They're going to be spending all of their days just going through and fielding requests to change microservices, and they will be miserable. Ultimately, the microservices world really, really needs a lot of trust. Where you really want to end up is embracing this radical notion that development and operations should actually trust each other to be pulling in the same direction and doing things in a way that's going to benefit your application as a whole. But that can be challenging. In particular, if we look back at the monolith days, it was just too easy to break everything. And so this trust was in very, very short supply for a long time. On the other hand, working back in the monolith days in that kind of more centralized development model, developers at least had a relatively easy time of knowing the different functions in the monolith and knowing where to go for docs and knowing how to figure out how they worked and knowing what changes were happening. Because ultimately, they could always go back to the central group of people that was trying to ride herd on the whole thing and ask questions. In the microservices land, okay, a good thing is that it's harder to completely break everything and it's easier to develop at scale, but it is very, very difficult, or it can be very, very difficult to understand which microservices are even running in your cluster, which of the ones that are running are no longer needed, how you're supposed to use the ones that are running in the cluster, who owns them if things go wrong. All of that information can be a real challenge to keep track of. And without that, the trust that you need for microservices to really work well is exceptionally difficult to arrange. That's the world where developer platforms started to show up, right? If you look at what you need to get real value out of microservices, well, if Jane wants to use these 2 microservices here, then the first thing, she needs to know how to talk to them. She needs to know things like what kinds of requests are supported, what parameters you feed, what the response is likely to be. Basically, she needs to know the API for any of these microservices that she wants to use. But even more fundamentally than that, she first has to know that they exist at all. Then she needs to know things like whether one of the ones she's trying to use has been superseded by an entirely different microservice that she hadn't heard about until it showed up just now. Ideally, she would know where to find documentation for these things so that she can go through and double check her understanding of how to actually use them. And maybe more importantly, so she can understand when things change and have a fighting chance of being able to change along with them. She needs to know how to figure out whether the microservices that she's using are working well or whether they're having problems. If they are having problems, she would benefit from knowing who to talk to if things are not working. The really challenging bit is that everybody in the development team has to know this for every microservice that they want to use. And that can get to be a real mess when you have lots and lots and lots of microservices. Worth noting, monoliths did have some of these problems as well. But the fact that development tended to happen in a somewhat more centralized way meant that the scale of the problem was different because everybody could always go back to the central team or people and ask questions, and that really had a major effect. Managing this fairly ridiculous volume of information is ultimately what the developer platform is for. So your developer platform could show you a set of microservices that you are interested in. It can surface the call graph that is relevant for these things, or at least it would be better to call it the dependency graph, right? Which microservices depend on which other microservices. It can talk to you about where the docs are for each of these microservices. It can talk to you about who the owners of each of the microservices are. This is a pretty big deal. Ideally, it would do this in a somewhat more graceful way than the diagram I just put together, but ultimately, it's still about keeping track of this volume of information that we have. In many cases, developer platforms have also grown into assisting with managing deployments or automating certain tasks, but at the root, you're talking about information and making information easier to find than about anything else. And that leads us into the service mesh. Okay. Service mesh 101. Microservices, as I mentioned earlier, are all talking over an unreliable, insecure network. This is a little bit problematic. The service mesh, in my case, I will of course be talking about Linkerd. Service meshes are an infrastructure component offering security, reliability, and observability at the platform level, which is to say underneath your application, across the entire application, ideally without having to change your application any. That last is important and often a bit of a differentiator between some of the things that Linkerd does and some of the different ones do. All right. Linkerd does all this by adding a proxy next to each application pod. A lot of service meshes end up using Envoy for proxies. Linkerd does not. Linkerd uses a custom-built microproxy written in Rust for performance and for security. But the purpose of the proxy is once it's in place, it takes over all of the network traffic into and out of the application pod and mediates and measures all of the communication happening between your microservices. So for example, I mentioned that the network is inherently insecure, not unsecure. One of the things that the proxies get to do, since they're mediating all the communications, is that they can enforce MTLS everywhere to deal with the fact that the network is inherently insecure. Part of MTLS, as opposed to TLS, is that we verify the identity of the workload on each end of the connection. So we know that a given microservice is talking to the microservice it means to be talking to, and we know that the one doing the talking is also the one that the receiving microservice believes it is. Linkerd actually uses Kubernetes service accounts as the basis for its workload identity. The service accounts tie back into Kubernetes RBAC and all of the other security mechanisms that Kubernetes has in place. So you end up with a nice case where the service mesh is taking advantage of an existing Kubernetes mechanism that you're probably already using to give you additional functionality. This is one of the ways that we talk about Linkerd being able to bring benefit in, even though you don't have to change your application. Linkerd also gets to do things like, given that we have these identities, we can introduce authorization policy all the way down to individual routes so that you can say things like, oh, this one microservice is allowed to get the list of users from this other one, but it's not allowed to change users. Or it's allowed to get the list of users, but it's not allowed to get the list of bank accounts or whatever. Another thing that we have to deal with is that networks are inherently unreliable as well. So this is another area where the service mesh gets to mediate communication to improve that. So for example, we can do things like if a request is made and fails, then the mesh can automatically retry it. The mesh can also do things like timeouts or circuit breaking so that it hopefully won't overload a microservice that's already in the process of failing. There's a lot of stuff underneath here that we can do. We can even do things like, oh, hey, this given microservice seems to be totally broken. Let's just take all of its traffic and route it to an earlier version that we know is okay. And all of these things can be done without any changes to the application. It is true, you do have to configure the mesh for some of the reliability mechanisms. We do not automatically know which things are safe to retry, for example. Finally, we get observability, where I said that the proxies mediate and measure all the traffic. So, for example, table stakes. any mesh worth its salt can surface the golden metrics: success rate, request rate, latency, so that we can do things like see, oh, this request works 100% of the time. We're seeing 20 requests per second. 99% of these requests finish in 12 milliseconds or less, but this one over here only succeeds 20% of the time, and most of its requests are going to succeed in 500 milliseconds. So it's slow and broken. That might be a problem. And then we can see that these in the middle are kind of varying, 75%, 80%, but at least they're faster. Now, without a lot of information about the application, the metrics by themselves are not instantly going to help you. It's a little bit interesting to look at this graph where I just made these numbers up. But if I were to see this in the real world, yeah, it's a little bit challenging to see how that one shown in green gets 100% and 20 requests per second when it's getting a different amount of traffic that's often failing coming in. So there might be something wrong with that microservice in the middle of everything, just for starters. But we would need to know what the application is doing to really understand that. Linkerd also gets to show you, as part of answering questions like that, it can show you live traffic. So it can actually show you a list of requests happening in real time. It can show you the most frequent requests being made between two microservices. There's a lot more stuff there than it can do. And some of that stuff very directly gets into, okay, what should a mesh do that can help out a developer platform? So let's first state absolutely the obvious. If you are running a developer platform on Kubernetes and you are not running a service mesh to deal with security on your network, you may be in an interesting position. You might need to supply security in some other way. Actually, you will definitely need to supply security in some other way. You may very well find that the mesh is the simplest way to do it, though. And ultimately, this is because if you have a developer platform, but you cannot trust what it's saying, or you cannot trust that you're really talking to it correctly, or you can't trust that your application is talking to who it thinks it's to, none of these things are very helpful. You actually need security. It's not optional. That is, of course, just the obvious thing. I think the most important thing to remember here is that the mesh is measuring everything happening in between the microservices. That gives it an enormous amount of information that it can work with. So, for example, the metrics, golden metrics, are nice, but the mesh actually knows a lot more than that. The mesh knows about every call that's being made as it is being made. So, for example, even with 4 microservices, there are a lot of different flows that we could have between these microservices. Here are just a few of them. And the mesh gets to see all of those as they are happening. So the mesh can actually build you the graph of calls that are really happening as they are happening. So it can tell you things like, oh, this is what's going on. These microservices talk to each other. This allows the developer platform to use the mesh observability data to dynamically construct a catalog of active microservices, which is kind of interesting. Developer platforms these days have dependency lists, but it is often a manually curated thing. That works, but it's a royal pain to manage as you change microservices around a lot. So it would be better to have the platform able to just get that in real time from the mesh. Likewise, once you're dynamically curating the call graph, it's a relatively small step to surface, hey, this microservice is not being used by anybody anymore. You can get rid of it. This all by itself can be a major benefit. It may sound silly, but I have personally talked to people at organizations where they left every single version of every microservice running for all time because it was too hard to figure out which ones were no longer being used. So this sort of thing can sound silly, but still be a big deal. The mesh also gets to see details of the calls as they are happening. So we don't get to just see, oh, there's a call that went between these two microservices. We can see things like that was a get, here was its path, here are the headers, here are the query parameters. We get to see all of those for every call that's happening. All of those details provide ready-made API examples, assuming the call succeeded, but we get to know if the call succeeded too. Linkerd actually already knows how to do this, already knows how to study the traffic and write Linkerd service profiles, which are used for well, partly they're used for controlling things like retries and timeouts, but they're also used for collecting metrics into more useful buckets for the humans to understand. And a really effective way to write those right now is just to tell Linkerd, hey, go study the traffic to this microservice and write me a service profile. It's really not a huge stretch to imagine the developer platform taking that same information and using it to jumpstart an open API specification for these calls as well. In short, the service mesh actually has a huge amount of information about what's going on right now in your application, ranging from the call graph to the golden metrics to the details of the calls that happen, which gives us some information about the API. All of that is information that a service mesh already has. The developer platform should really go ahead and start using this to reduce toil on the platform engineers. Also worth noting, as developer platforms extend into task automation, the mesh provides low-level tooling that the platform can use to help with that automation. So a really simple example is that Linkerd can support canary deployments absolutely anywhere in the call graph, where instead of just flipping a microservice, we can introduce version 2, start feeding a little bit of traffic to it, see if that works. If it does work, feed it a little bit more until eventually we transfer all the traffic away from the old version and get rid of the old version. All of that is machinery that Linkerd already has in place, and it can guide those rollouts by providing data back to the automation about whether your new version is working or not. Okay. It is now time for the demo. Everybody cross your fingers. The demo is really simple. Ben Lambert, one of the Backstage maintainers over at Spotify, wrote a proof of concept for a Linkerd plugin for Backstage. This is a thing that there's apparently a long-standing issue about Backstage saying, hey, it would be nice to have a Linkerd plugin. Ben and I got to talking, and Ben just kind of went off and wrote a proof of concept to make it work, which was pretty cool, especially because it took him not very long to get it running. It was really awesome. The plugin does one of the things that we just mentioned. It is going to use Linkerd to put dynamic dependency information into Backstage. Normally, this information about microservice dependencies is stuff that you have to manually curate in Backstage, but with this demo plugin, it does it automatically. I'm going to be doing this with the world famous Faces demo, which I'm sure is not world famous. I did go and do manual stuff for Faces in Backstage, and I will go ahead and put that up on the Faces repo once this is done. So here we have a running Faces demo. And here we have a Backstage catalog showing a bunch of stuff with Faces. And just for the fun of it, I can also show some of the same things with Linkerd Viz as well. So I can go over in here into Linkerd Viz, and we can see some information about things that are running poorly, many of them, in the Faces namespace. Faces is deliberately a terrible, terrible application, so they're supposed to be running poorly. But here's the interesting bit, is I can go over and pick the face component in Backstage, come over here, and if we give it a second, this bit here that tells us that emissary is talking to the face workload, which is talking to the color and smiley workloads. I didn't tell Backstage about that. Backstage just went and read that out of the cluster for me. I can come over, and if I click on the Faces system as a whole and then go into the diagram, actually, you know what? Let me do this a little bit differently. Let's get rid of some of these things here. I don't want to see the users, but I can see the APIs that are in here. If I come back to look at APIs directly, then I can see, let me tune this a little bit. I don't really need to see owners right now, but I do want to see what provides what. I also don't need to see what's a part of what. Let's just focus on the APIs. But if I come up here and give it more depth, then I can see Backstage automatically drawing out things like which APIs are being used here. And once again, if I go back over here, I can take a look at the runtime dependencies for any of these things via the plugin, which is pretty cool. One final thing that I wanted to point out here is if I go back, actually, let's switch back to the face component. If you come over here, you get to see emissary talking to face workload, talking to color and smiley. That's particularly interesting because if I come back and look at that in Linkerd Viz, it is true that I can drill all the way into this view and see emissary talking to face. But if I just start off looking at the face's namespace, I don't get to see in Linkerd Viz that emissary is talking to me here. I have to go drill further down, whereas Backstage can surface it immediately because of the way this is working. So again, proof of concept, very, very early days with that one. That's something that I think is going to be a lot of fun to expand on as we go and start seeing how many of the things I was just talking about we can actually get running in here. But the summary of the whole thing is that, yes, getting the most benefit from microservices requires a truly ridiculous amount of information. Developer platforms can help with that, but if we can tie the mesh into the developer platform, then I think the developer platform can help a lot more. And with that, I am done. I shall emulate Stevie and stop sharing my screen.
Here we are.
I have no idea if we have time for questions or not, but if we do.
Well, I don't see any questions at the moment. So if you want to ask questions, feel free. We are actually running up against time, right on time, Flynn.
Yeah,
Well
you
done.
got a lot of great comments and
cool.
some comments that might be fun to respond to keep the conversation going. But thank you as always, Flynn. That was great.
Cool.
And
Glad you enjoyed it.
all right.
Yeah, I was also, I'm sorry, there was one other thing that I wanted to mention that is, you know what? I'm just going to mention it instead of bringing the slide up. Service Mesh Academy next month, we're going to be talking about Linkerd, not on Kubernetes, the easy way. Be there or don't, you know, whatever. And also the shiny new Buoyant Enterprise for Linkerd. You can check that out at buoyant.io. Highly recommended. Awesome stuff. Yeah.
Awesome. Thank you so much.
Very
Flynn.
awesome. And Flynn, you can put the link to where people register for that in the chat. So
I will do that. Oh, and I see one comment. Is the plugin, the Linkerd plugin, available for others to try? Not at this very moment. I am going to be talking to Ben to figure out how we get that to be something that other people can play with, which on the one hand will be cool, and on the other hand is kind of terrifying because it is really early at this point. But I mean, this is the way to get feedback on it, right? So
Exactly.
All right. Let me stick a couple of links in the chat. Thanks very much.
Thank you.
thank
See you
you
later.
always, Flynn. Great to see you.